Okay. Turn that off. Okay, so we're going to start off with elements. How many elements are there? You're close, Kevin. 117, 118 elements. Yep, 118 elements. Of this, was it 82? Are naturally occurring. That means the rest of them are synthetic elements, are elements that are created. Okay. Sorry, 88, not 82. Okay. The first 92 elements are, sorry, first 88 of the first 92 elements are not radioactive. After element 92, which is lead, all of them are radioactive. Okay. There are a few others: astatine, francium, promethium, and technetium. They are also radioactive. But what is an element?
Isn't it a form of mass?
So elements have mass, and they make up all matter, but an element is the smallest substance that can't be broken down by chemical means. Now, when it comes to elements, elements are composed of atoms. And atoms are the smallest particle of an element. They are not the smallest particle. We can break elements down further, we can make atoms down further into subatomic particles, so subatomic smaller than atom. However, if we do break an element or an atom down into a subatomic particle, it's no longer going to contain the same properties that make that thing that particular element. So, for example, carbon has carbon-12 has 6 protons and 6 neutrons. So there are 3 subatomic particles that we will deal with in this course: protons, neutrons, and electrons. Carbon has 6 protons, 6 neutrons, 6 electrons. That is the very thing that makes carbon-12 carbon-12. If we vary those subatomic particles, then we change the identity of the species that we are dealing with. So if I, let's say, remove an electron, and I have 6 protons, 6 neutrons, and now 5 electrons, I no longer have a carbon atom. I have something called a carbon ion, and specifically a carbon cation. If I add 2 neutrons, so I have 6 protons, 8 neutrons, and 6 electrons, I'm now no longer dealing with carbon 12. I'm dealing with a different form of carbon called carbon 14, and that form is radioactive. So all of these things are the subatomic particles are what make that atom what it is. Now, atoms exists in particular states, right? Atoms, and for that matter, elements. They can exist as one of three states. They can exist as a solid, a liquid, or a gas. Now I know somebody, well, there's a fourth state of matter, it's plasma. Yes, that's true, but elements don't exist as a plasma. They can exist in one of these three states, solid, liquid, or gas. And we'll talk about in a little bit how those can vary. Elements have names. Just like you or I, elements have names. However, they don't have the same type of name that we do. Our names are proper nouns. That's why the first letter of your name is capitalized, because it is a proper noun. The names of elements are not proper nouns, right? If Jasmine were my friend, say, oh, that's my friend Jasmine, and I'd capitalize her name with a J. If carbon were my friend, I wouldn't say that's my friend carbon and capitalize carbon with a C. It's not your friend, the element, it's just the element itself. Okay? In the same way that you don't capitalize table, because it's not the name of the table's name is obviously Frank. So we don't capitalize the names of elements, it's not their personal name. No one is able to talk to elements to figure out what their personal names are, so we don't know. So we just don't capitalize the names of the elements. Okay. Now, the names of the elements come from all over the place. Okay. They come from Latin. Right? So for example, the element potassium. Right? You would think, oh, potassium. See, there I go. I went and capitalized the name of the element. Right? There's our potassium. The symbol, elements have symbols because names of the elements sometimes are too much. So they have symbols as well. The symbol for potassium is K, which doesn't make a whole lot of sense because there's not a K in the word potassium. Okay. Just like sodium. The symbol for sodium is Na, which again doesn't make sense because there's not an N or an A in the word sodium. And that's because the names of these elements come from different languages. These both come from Latin. K is actually from Kalimia. And sodium is from natrium. And this is why if you go into the hospital and they check your potassium, and if it's too high, they might say that you are hyperkalemic. Or if your sodium is too low, they would say you are suffering from hyponatremia. Doctors want to be fancy, and so they use the Latin words. It's come from Latin. Just like iron. The symbol for iron is Fe, which makes no sense at all unless you know Latin and you know the word for iron in Latin is ferrum. We also have elements that are named for properties. Okay, so for example, iodine comes from the Greek word iodes, meaning purple. We have elements that are named after places. Yes, I keep on muting. I constantly keep muting you guys.
On my end, you're perfectly fine. I don't know about
No,
the
no,
rest.
no. I'm not muting myself. I'm muting you guys.
No, they're saying they can't hear you.
Oh,
It might just be their connection.
Sayla, you can't hear me?
You cut off in like certain parts.
Hmm. Okay. Where was I? Oh, so we're saying they're named after places. California, named after. Anyone take a guess?
Let me guess. Nebraska. No. California.
Exactly right. It's Nebraska. No, it's California, right? Or that's not spelled correctly. Where is it? It's E-L-I-U-M. Berkelium. Anyone know where that one's from?
No.
Berkeley says
Berkeley?
Berkeley.
Berkeley. Berkeley. That's exactly correct. Yeah, that's where the element was discovered, was Berkeley. If you discover an element, you usually get to name it. Or it's named after people. Einsteinium. Or Nobelium. Einsteinium, named after Franklin Einsteinium. No, Albert Einstein. And Nobelium, named after Alfred Nobel. Which, does anyone know what Alfred Nobel was known for?
I'm going to make an assumption is for Nobel Peace Prizes, you know?
No, it's actually not that. The Nobel Prize was something that he started, but it's not what he's known for. He's known for creating TNT, dynamite. So he started the Nobel Prize after making lots of money selling explosives, and that explosives that were used in world wars, and then decided that he didn't like that. So anyway, so Californium is, what is that? Where is it here? I think it's CA, CM. No, that's Curium. CF. Californium has the symbol CF. Berkelium is BK. Einsteinium, I think, is ES. Where are you? Yeah, there you are. ES. Nobelium is NO. So all of the elements have a symbol that corresponds to that particular element as well. Okay. The symbol is at a minimum one capital letter. However, we have 118 elements and only 26 letters. So the second symbol, if necessary, is going to be lowercase. Okay. So things like oxygen, carbon, nitrogen, boron, sulfur, these elements only have one symbol. Potassium, one symbol, but most of the elements are going to have two letters as their symbol. Okay. Um, my favorite element, in case you were interested, is tungsten. Can anyone guess what the symbol for tungsten is?
W.
It is W. How did you know that?
Oh, I print out the papers you gave us on the web.
Oh, okay. It's W, which comes from the German name for tungsten, which is Wolfram. So, all right.